So now we will solve the problem 2 of Codechef Starters 73 Consecutive Xor, which was of Div2. So what the problem says, chef has an array of length n. He can perform the following operation on A. Select an index I, which is from 1 to n minus 1, and select an integer x, which is from 1 greater than equal to 1 and less than 2 to the power 20, and set ai equals to ai xor x and ai plus 1 equals to ai plus 1 xor x, and determine if chef can make all the elements of A equal by applying the above operation any number of times, possibly 0. So the question says we will be given an array A and we have to make all the elements of array A by performing these operations. And in one operation, what we can do, we can select an integer x and select an index I, and we can change the element at that index to ai or x, and the next element to the ai to ai plus 1 or x. So let's see how we can do it. So suppose initially our array only consists of 1 and 0. So suppose we have our array as 1 0 0 1 1 0 0 1. Okay, so can we make this all the elements of this array equal? So the answer is yes. Let's see how. In this case, we can make the array either 0 0 0 0 or 1 1 1 1. Both the cases are possible. Let's check how. So in this case, 1 0 0 1, we can select these two numbers and our x equals to 1, and we can XOR with these two numbers, then our array will become 0 1 0 1. Now we can select these two numbers and again x equals to 1, and now again we will XOR with those elements and our array will become 0 0 1 1. Now finally we will choose these two elements and again x equals to 1, and we will XOR with 1 with these two elements and our array will become 0 0 0 0. So in this case, 0 equals 0 equals 0 equals 0. So our condition is satisfied. Now I have also told you we can make this array to 1 1 1 and 1 also. So let's check how we can do it. So our initial array was 1 1 0 0 1. So in this case, we can take our x equals to 0 and we can select these two integers and XOR with these two integers with sorry, we can take our x again equals to 1 not 0, and we can XOR with these two elements 1 and 1 here. So our array will become 1 0 XOR 1 0 XOR 1 comma 1. So this will become 1 1 1 1 because 0 XOR 1 is 1. So in this case, 1 1 1 1 is also achievable. So again our all the array elements are equal. Now suppose we are given an array like suppose 1 1 and 0. So can we make this array to 1 1 and 1? So the answer will be no. But can we make this array to 0 0 0? So the answer will be yes. Let's check how. So to make this array to 1 1 1, see these two elements are already 1 here in both these arrays, but this is 0 and this is 1. So to make this 0 1, we need one more element, which is we need one more element. So if we take this element, then if we convert this 0 to 1, then this 1 will convert to 0. So again, we will have 1 0 1 left to be converted to 1 1 1. Again, now this one is equal to this one is equal to this one, but this is 0 and this is 1. So if we will try to make this 0 again to 1, then it will convert to 1. But then one of the elements, either this or this, will again turn to 0. So what we can say, that 1 1 0 can't be converted to 1 1 1, because as soon as we want to convert this 0 to 1, this one will get converted to 0 because there is no element to the right of this 0 to select with, to go with. And when we will convert this 1 to 0, then we will have to make this 0 again equal to 1. So for making this 0 again equal to 1, we have to select this element either, or either this element. So in that case also, if this 0 gets converted to 1, then this 1 present already before this step here will again get converted to 0. So this 1 0 can't get converted to 1 1 1. But now suppose this was 1 1 0, and we have to convert this to 0 0 0. We can make this array to this obviously by taking x equals to 1 and choosing these two elements. When we take the XOR of 1 with 1, this will be 0. This 1 with this one, this will again be 0, and this is already 0. So this is 0 0 0. So what we can infer from this situation is that suppose there is any array with 1 and 0 only. Suppose 1 0 1 0 0 1 1 0. Just count the number of 1. It is 1, 2, 3, and 4. The count of 1 is 4. Now count the number of 0. 1, 2, 3, and 4. So the count of 0 is also 4. So what we can say is that if any of them is even, we can, if any of them is even, we can make all the elements equals, all the elements of the array equal. Why? Because suppose 0 is in even number, so all of the 0 can be converted to 1. And there is already 4 ones there, and all of the 0 when get converted to 1 will make the all the elements of the array equals to 1. Also in this case, the count of 1 is also even, so we can make all the 1 also to 0. So in this case, 0 0 0 0 0 0 3 3 6 7 8 zeros or either 8 ones, both the cases are achievable. You can try it. It's simple. It's so simple. So I can also show you. So let's check. It is 1 0 1 0 0. So our initial array is 1 0 1 0 0 1 1 0. Just let us suppose we want to make all the elements equals to 1. So we have to convert this 0 to 1. To convert this 0 to 1, we have to XOR it with 1. And when we will choose this 0, we have to also choose this 1 also. So we have to XOR this with XOR this element with also 1. So after the first operation, our array will become 1 1 0 0 0 1 1 0. Now this is again 0. So we have to convert it to 1. So we have to XOR it with 1 to, since we have chosen this index, we have to choose this index also, because left part of all this is already converted to 1. So we will not change the left hand side, and we will just move to the right hand side. Now we will take this XOR of this element with 1 also, because we have to take two elements at a time. So after the second operation, our array will become 1 1 1 1 0 1 1 0. So in the next step, we can choose these two elements, and then our array will become 1 1 1 1 1 0 1 0. In next step, we can choose these two elements, then our array will become 1 1 1 1 1 1 0 0. And last step, if we choose these two elements, the both are 0, so the both elements will get converted to 1, and our final array will be 1 1 1 1 1 1 1 1. So in this case, we can convert all the elements to 1. Why? Because the number of 0 present in the array, which was 1, 2, 3, and 4, was even. Similarly, we can also make all the elements of this array equals to 0 also, because the number of 1 present was also also even. Now check, suppose this was the case, 1 1 0. In this case, I already explained you, we were not able to convert all the elements of the array equals to 0. Why? Because the count of 0 was 1, which is odd. But in this case, the count of 1 was even. So we were able to convert all the ones to 0. So when we converted all the ones to 0, our array becomes 0 0 0, and the condition was satisfied, which was all the elements of the array was equal. So what we can infer finally is that for any array with 1 and zeros only, just take out the count of 1 and count of 0. If any of count 1, suppose it is count 1 and it is count 2. If any of the count 1 and count 2 is even, then we can make the all the elements of the array equal. And if both of them are odd, then this is not possible. So this was the case when the array elements only consist of 1 and 0. But you can ask that what if the array elements don't consist of only 1 and 0, rather consist of every other element. So in that case, what we can do, just check for, just suppose take any bit 2 to the power alpha. Suppose you take this bit, and there are array elements a1, a2, a3, a4, a5 till an. So in that case, what we can do, if this 2 to the power alpha is set in A1, just consider it as 1. And if it is not, suppose not set in A2, just consider it as 0. So again, this problem will be finally broken down into our sub problem, which is already solved, which then will become our array as 1010. Here 1010, if anything, will mean that 1 will mean that this particular bit is set, and 0 will mean that this particular bit is not set. And suppose we have to make this 1 to 0, just what we have to do, we have to just XOR of this A1 with this 2 to the power alpha. Then this bit will get, if 2 to the power alpha is set in A1, then this bit will get unset, which will then make this element 0. And if it was set in, if it was not set in A2, and if we XOR it with 2 to the power alpha, then it will make the 2 to the power alpha bit set in A2. Then in turn, it will make this 0 to 1. So what we can do finally is that, suppose we are given array A1, A2, A3 till AN, just run a loop from 2 to the power 0 to 2 to the power 64, or whatever the limit it is given. And for any particular 2 to the power I, check if it is set in A1. If it is set, make it 1. If it is not set, suppose in A2 it is not set, make it, consider it as 0. And in that case, your final array will become like 10, consist of 1010 only. And check for each case count of 1 and count of 2. If in a count of 0, sorry. If in any iteration, means like if in any 2 to the power I case, if count 1 and count of 0 is both are odd, then in that case we can't make all the elements of the array equal. Why? Because there will be there will consist of some elements which will consist with, in which the 2 to the power I will be set, and there will consist some elements which won't contain 2 to the power I. We won't be able to make all the elements either consist 2 to the power I or do not consist of 2 to the power I. So I think this cleared your approach. Now let's check the code. So here is the code. Let me explain it to you. So what we have to do, we have first input our n, then we have input our array. And since we have to check till 2 to the power 20 and only, so I have run a loop till 0 to 20. And in each loop, I have made t equals to 1 to the 2 to the power I. And I initialize my count 1 equal to 0 and count 2 equal to 0. Count 1 will store the number of elements in which 2 to the power I is set, and count 2 will store number of elements in which 2 to the power I is not set. And then I have run a loop over my elements. And if t is set in AJ, then this element will be positive. So this condition will become true. Then C1 will get incremented, and if not present, C2 will get incremented. And after coming out of this loop, if C1 is odd, also the C2 is odd, means both are odd, then in that case we can't make the elements of the array all the elements equal, because there will be a case in which the suppose for 2 to the power for 2 to the power some I, we got that C1 is also odd and C2 is also odd. In that case, there will be an element which won't be, in which 2 to the power I won't be set, and there will be some elements in which 2 to the power I is set, and we can't be able to make all the elements either 2 to the power I set or either 2 to the power I unset. And after running this whole loop, if we never found a case like this, then we can output our answer as yes. So I hope this cleared your question. Thank you.